You're going to love this. This is going to be the story of Echo the Bat. And throughout this session, we're going to relate the story of Echo the Bat to ecosystems, biodiversity, remote sensing, and all types of really fun things that relate back to science process skills in terms of observations and inferences with some activities. And so I just can't wait to dig into this. So let's start by clicking this link. This is the digital version of Echo the Bat. And so you can begin this, and you have this available so that you can read it at any time with some really wonderful illustrations. Okay, and so I wanted you to be aware of that being in existence. As I mentioned in this morning's session, that Echo the Bat, the book itself is no longer being printed, and so this book, which is a NASA book, really is something that is a great addition to have in your classroom. And so if you are interested in Echo the Bat and want to do the full training so that you can borrow the Echo the Bat kit from us at the NASA Education Resource Center, then please make sure that you reach out to me so that you can do that. And there are benefits to having an actual copy of the book. The book has some pop-up tabs in the second half that relates the Landsat images to what the terrain is like on the Earth. And so it's a really good conversation on perception that we're going to have, and you'll see how the book helps us address that with students. Okay, so we're actually going to watch this video of Echo the Bat.
High in the mountains of Arizona, there's a forest of tall ponderosa pine trees. A colony of big brown bats makes its home under the loose bark of the pine tree. A mother plans to raise her babies here. When the warm days of spring lead to summer, a baby bat is born. Mother bat calls her baby, and her baby calls back. Like echoes in the canyon, she names her baby Echo. Echo's bones are very light and aren't strong enough to stand or walk on. He hangs upside down, using his feet to grab onto branches or bark. His wings are made of long, finger-like bones, covered with stretchy skin. His tiny, fuzzy body is covered with brown fur, like a mouse with giant ears. In the evening, just as the sun is setting, Echo and his mother are resting under the tree bark.
A snake! Echo, quickly come here.
Where are we going?
We need to find another home because there are snakes here, and snakes like to eat bats. We need to find a new roost.
Echo isn't big enough to fly on his own. He holds on tight to his mother as they fly out of the nest. He's never been flying before and enjoys the feeling of swooping up and down and around the trees.
I can't wait until I'm old enough to fly on my own.
The next night, Echo wakes up in his new roost and finds his mother getting ready to fly from the tree.
Echo, I need to leave you now so I can find some bugs to eat. Wait here and I'll be home soon.
But I want to go too.
You don't know how to fly yet.
But I want to learn. When can I learn how to fly?
You'll be ready soon, but now you've got to wait here. Be careful not to fall because there are many animals in the forest that prey on bats and eat them for dinner.
With that warning, Mother Bat flies from the tree to hunt for bugs. Echo and the other bats stay nestled under the bark of their tree. They huddle together to stay warm, frightened by the thoughts of owls and snakes that might prey on them for food. The babies begin to call for their mothers. Mother Bat hears Echo calling her. Echo can barely see his mother returning in the moonlight. But Mother Bat knows Echo's call well enough and can find him, even if there are hundreds of baby bats in the nursery.
Mother, I'm so glad you're home. I like it here with you.
I like it here too. But soon the weather will get colder and there will be fewer bugs to eat. Then we will take a long trip and fly to a new home.
But I don't want to leave.
Our colony flies to the same cave every year. This is what it means to migrate.
How will we know the way to the cave?
As we fly, we will see shapes on the land made by rivers, lakes, and mountains. The patterns of these shapes help guide us to our new home in a cave. At this cave, we will meet other bats. We will sleep in our cave all winter, hibernating until spring.
It was this story that Echo loved so much. His mother told him about the adventure to the bat cave every night. Now Echo is a month old and has grown as big as his mother. It is time for him to learn to fly. He lets go of the tree and begins to flap his wings, but he just falls toward the ground. He flaps his wings faster and faster. Then Echo starts to fly. He flaps and flaps, flying up and down around the trees.
This is very hard to do. I'm getting really tired and hungry too.
Start eating bugs, Echo. They're all around us.
I can't see any bugs. Where are they?
You have to use echolocation. Listen to me.
Echo, like all bats, can see very well. Bats have other senses that help them get around at night and catch bugs. Mother bat calls out with an ultrasonic sound and listens carefully for the sound to return.
Do you hear that? Echo?
Yes.
The sound bounces off the bugs and comes back, like an echo. Fly toward the echo and you'll find the bug. The faster the sound echo comes back, the closer you are to the bug.
I think we've gotten.
As it gets darker, echolocation helps us bats see larger things like trees. So remember to chew quickly. The sooner you empty your mouth, the sooner you can make your sounds again.
The next evening, Echo and his mother leave their roost to hunt for bugs. Dark clouds fill the sky. Echo is frightened. The sound of thunder hurts his ears.
Mother, where are you?
But there was no answer. Echo can't see or hear his mother anywhere. Lost and alone, Echo clings to a pine branch. He wonders if he will ever see his mother again. Echo thinks of the long journey to the cave and his mother's story. He is scared to go alone and wonders how he's going to get there.
I remember the story my mother told me about going to the cave. I'm sure I can get there. Tomorrow night, I will find the cave.
Echo falls asleep, dreaming of the bat cave.
Okay, so that's where the video ends. That's really just the first half of the book, and then the second half of the book is Echo's journey back to finding his mother, and that's where the remote sensing conversation comes in and Landsat images come in, and Echo goes through 5 different habitats, and so he has to find things there to survive, something to eat, and also a particular shelter that he has to live in. And so we'll get to some of that here in a bit. Let's get back to science process skills, though. This morning we talked about the difference between an observation and an inference, and one of the very first activities we're going to talk about in the Echo the Bat kit is called What Are We Looking At? And so we're going to address with our students directly what an observation is. And so we use our senses to see things like colors and shapes. And we also can hear things with our ears, sounds. We can smell things, smells. We can feel things with our hands and fingers. And we can taste things with our tongue. And so all of these things that we can sense with our senses are observations. And so in this image, I want you to make an observation. And so be careful. We do not want anybody to say what they think the image is of, because that would be making an inference, right? That's taking all of the little observations and coming up with an idea about what something is. We don't want to jump to a conclusion here. Instead, let's focus on observations. So observations might be that there's round red things. There is a yellow irregular shape here. Notice how I'm not saying what I think this is. I'm just commenting on the things that I can see, the shapes of things, what the texture of those things might be like based upon their appearance. I can't smell anything in this image. I can't touch it and feel it, but I can describe the texture some, like I said. Definitely can't taste it. and it's not making any sounds. It's not a video. So I'm just relying on color, shapes, and patterns like that. And so I noticed that this green rectangle has a lighter side here and a darker side here. Beneath or behind this green object to the sides is this blue pattern, which seems to be made of a different texture. We've got more rectangular block-like or rectangular pieces. Careful there, I don't want to assume that these are blocks. There's a black one, here's a blue one. And so after we make our observations, then we might want to make an inference based off of those observations. So now that we've made some really good observations, let's put them together to come up with an inference. So many people might say that this looks kind of like the top of a fishing pole and that this is the water beneath. Or other people have said that this is like a train, a wooden train that's crossing a bridge over what seems to be drawn water out of chalk. And so we can get two very different opinions with the same information. Remember, that's one of the keys to teaching, or one of the attributes, I should say, to teaching the nature of science, right? That scientists can look at the same set of information and come up with two different ideas about what's in front of them. And so when we get to a higher elevation away from the surface, we can get a bigger picture. And that's the purpose of this activity, is to help students understand that when bats are flying, they can actually get up higher above the terrain, and it gives them a bigger picture of what they're looking at. And NASA also does something very similar to that. Whenever we launch satellites into space to observe the Earth, we can learn about the Earth from space and get a bigger picture of what's happening on the Earth so that we can make more informed decisions. And so now, whenever we look at this picture, we can observe it differently, as if we were closer to space or higher up in the sky. And so now we can actually tell that that blue image does look like some type of stream that might be flowing. And so again, let's be careful. I'm making an inference there. So the observation would be the texture of the piece that's going through the middle seems to be three-dimensional, whereas everything else around it might be two-dimensional in texture. So this might be drawn on. So there are blue lines that kind of flow or bend in places, and then there are green lines that are very straight and throughout. There's not very many bends to any of these green lines. We can also see some tan-like object that is crossing this blue, what we said may have been like streaming lines. And so if we're going to make an inference of this image, then we could definitely say that those people that thought this was a fishing pole in image 1 are going to see this differently, right? So when we get more scientific observations, our theories about what we're looking at can change. Another attribute of the nature of science that we talked about on day 1. And so this definitely is looking a lot more like a wooden toy train that's got some chalk drawings around it. There's a river that this bridge is going over top of, and then these might be fields surrounding it. And so when we get to a higher up image, we can actually see some new observations. We've got these really dark objects over here. There seems to be a darker shade here as well. And then our tan parts, you'll notice that there is some type of cross pattern that's going on here. And so what inferences can we make of this image? Well, we could say that these are like shadows being cast by the sunlight. So this setting where people are playing with this toy either is by a really bright light or is outside, maybe on the sidewalk, and this is afternoon or in the morning, close to noon, where the sun is just casting a shadow, a very small shadow from this object. We could also make the inference that there are two different train stations up here. And so one is coming from over here, and then this one is coming from this side. And so there's possibility another train over on this bridge heading in this direction. So let's get up even higher and get further off the surface of the Earth, like NASA does with their satellites, or like Echo does when he's trying to find his way home in the Arizona desert. And so, wow, taking a look at this image, I've come to find out that my inference was incorrect, and that this train is actually, this is one loop of train track. And so there are not two separate train tracks. This is one, and they just cross here. But we also can see what appears to be some squares. And these squares are colored in so that they're orange, and that there is another object that is in between the squares here. And so if I'm going to make inferences, I would make the inference that this is like a little community where people live, and maybe they are preparing to ship some of the product that's come out of the farming fields onto the train to another city nearby. And that this is a bigger river system that's crossing underneath of the train tracks. That's why we've got bridges here. So yeah, you can tell that getting a better perspective of the planet would help us learn a lot more about what's happening in smaller regions, or not just limit it to what's around us on the ground. And so we use our senses to make observations. And so one of the other activities in Echo the Bat is the smelling activity that you do, called using our senses. And so here what you'll do is you'll pick a volunteer to move a smelling item, and then another volunteer to be blindfolded. And you'll put the volunteer that's blindfolded in a chair and put them at the far end of the room away from the door. And they're going to take the volunteer that's going to bring in the smelling item outside of the classroom door. And that's where you want to give them the smelling item for the very first time. Don't even bring the smelling item into your classroom, because any of the odor molecules that diffuse out into the room are going to actually mix in with the air and actually make it harder for the student to sense the smelly object. And so what are some really good smelly objects that you can use? Well, I like to use really good smelling objects. So peppermint oil, other types of vanilla like oils or scents that you can just get in Walmart or Dollar General or somewhere, you know, that has like those kind of extracts available to you. Lemon extracts are really good and scenty. And so what you'll do then is have the student that is blindfolded just raise their hand the first time they smell something new. Don't tell them what it is that they're going to smell, and watch how that student that enters the room with the smelly object, how close they can get to that person before they can smell the object. And so you need to instruct that volunteer, when the student raises their hand, you need to stop moving. And it's really important that you do that, because you know kids, they're going to want to get up as close as possible, and you want to make sure that they're being respectful of everyone's space. So you can repeat this over and over with different scents until a couple of volunteers have a chance to try it out. And so this is just to lead into the conversation about what human senses can you name, okay? So we've witnessed vision when we were looking at what are we looking at, and seeing how our sight can help us see things from a distance, and how smelling these scents, our noses have given us an idea about how close certain smells are to us. And so humans use their noses to detect smells. We also use our fingers and toes to touch and feel things. And those are things that we can actually get an idea of what's around us without even using our eyes. We can close our eyes and touch and feel things to get an idea of the texture and what it is that maybe we're interacting with. Humans also use their tongues to taste things. Things usually taste good if they're good for us and healthy for us. Kind of like how Echo the Bat, he eats bugs and he likes the taste of bugs, whereas humans may not like a particular taste of bug because it's not good for us to eat. And then we also use our ears to hear and listen to things. That gives us an idea of what's around us. And so all of these things help us sense things that are happening in the world. And they also help us make observations. And a few of them are particularly helpful in letting us know how far away things are. Smells can help us detect how far away we are from a certain source of something that's really smelly or stinky even. It can warn us of danger. Don't go close to that smell. There could be danger. Also, whenever we see things, we have a direct view of how far away things are from us. And then by hearing with our ears, we can get an idea of how far away things are from us, from how loud they are, or how the pitch changes as things get closer or further away. And so what about bats? What bat senses can you name? And so Echo and many other fruit bats, just like Echo the bat, they'll use their nose leaf to actually smell things. There are little holes that go in so that they can have smell receptors, pick up on odors. And they also use their nose leaf, which is kind of like an angled flap of skin, that they can actually steer waves around. So when they send out an echolocation wave, it can come back and they can redirect that wave with their nose leaf to help get a fuller picture of what's around them rather than just what's up in front of them with that one wave that they send out. And so bats also use their feet to touch. They do this to hang upside down while they're sleeping in caves or on trees. And the reason that bats sleep upside down is actually because their wings are very thin and fragile. And so they're not as strong as a normal bird's wings. And so they actually can't take off flying by just flapping their wings. They have to drop from the tree and then go into a glide. And that allows them to start flying. Bats also use their eyes to see during the daytime. And so many people think that bats are blind, but that's not the case. It's just at nighttime when they do most of their hunting, it's harder for them to see. And so they need to use echolocation to make up for their vision not being as good at nighttime. And so even though humans do have these similar senses, sometimes people will not have a very strong sense of smell, or maybe they're blind and they won't be able to see things, and they can use their other senses to make up for some of the disadvantaged senses that they have. And so echolocation and using their hearing, well, that's why bats have such big ears, is kind of a way for them to make up for their really bad night vision. And then bats, of course, use their tongues to taste insects. And so most bats can eat about 500 mosquitoes in 1 hour. Wow. And so we talked about their ears and echolocation. And so actually bats have the best of all land mammals hearing. And so why are their ears so big? It's so they can collect more waves from echolocation at one time. Okay, and so if you're lucky enough, maybe you'll know somebody that has bats that you can bring into the classroom, an expert to talk about bats, and you can let your students feel the fur of a bat and do this next activity called using our senses of touch. And so textures all have different feelings. And so what you're going to do is gather different materials like sandpaper, cloth, or a blanket, and you're going to let your students feel those different textures and describe them with only one word, such as gritty, fluffy, hairy, smooth, silky, and you're going to make a word wall of these texture words that your students come up with. And so challenge your students to add more and more texture describing words to your word wall. So here's an example word wall. And then what do textures look like? Right? Whenever we look at images of maps that were created by Landsat satellites, we're looking at an image that's taken from high up, way off of the Earth, miles and miles, about 400 miles above the surface of the Earth are the Landsat satellites that are orbiting around the Earth, and they're creating images by something similar to echolocation, but we call it remote sensing, and we'll talk more about that. But the information that that satellite receives from the returning light rays that come and bounce off of the surface of the Earth are used to generate colored pictures. And so those colored pictures can actually tell us a lot about the textures on the Earth, whether there's mountains, whether there's rivers, whether we're in a city area. And so this activity is going to help us relate that concept of maps being able to show texture. So we're going to take some of those materials that we used and that we described textures with using our texture words, and we're going to take a sheet of paper and we're going to set it over top of that material, and we're going to rip the wrapping off of the crayon, and then we're going to hold the crayon flat and color over top of the white sheet of paper that's sitting on top of your particular material. And so you'll see that this thing that we described as being smooth would look like this, and then this thing that we described as feeling flaky would look kind of like this. And then something that might be gritty would look like this. And so you can try this with all of your textures. And then finish it off by taking just a blank sheet of paper, crumbling it up, and then unfolding it and taking the crayon and just, again, coloring over top of the surface with the flat crayon. And then what you'll see is the ridges that were made by crinkling the paper are highlighted. And so this looks kind of like a mountain range would look like in a Landsat satellite image. And then over here we have where it was left flat. This is what a flat texture would look like on the Earth when we're looking at Landsat images. And so this is Landsat 7. This is exactly the instrument that I'm talking about that creates these satellite images, like the one here of Arizona, where Echo the Bat lives. And so it orbits around the Earth and gets little sections of the Earth at a time. And what it does is it sends out light rays, kind of like echolocation, but it's not sound. Instead, it's invisible light. We can't see this light with our eyes. And then it goes down and it hits the Earth, and then it comes back up. And it times how long it takes for that to reflect back and to be received by the satellite. Just kind of like how Echo the Bat sends out its sound waves, and then the sound comes back. And just like his mother said, if it comes back sooner, that lets you know that you're closer to the bug. Well, same thing with these light rays. If they come back sooner, that means that it's bouncing off of like a really tall mountain. And so we can see here in this Landsat image of Arizona how the mountain range here is colored in with this red color. It's very visible seeing this mountain range that goes through. And then above it, see what seems to be a really light colored area, kind of flat. This is the desert that Echo the Bat ends up in. And then over here is the other side where there are some cities and communities that Echo visits as well on his way back to the cave. And so you can continue this activity by getting some atlases and using these Landsat images and compare and contrast the types of things that you can see using Landsat images and the things that you can see with an atlas. And so here's a sample question from our activity kit. Predict the features you see in this image. For example, do you see a lake or river? How do you know that it's a lake or river? So here it's all about the inference making and then using our observations of the image to back up our inference, which is what the scientific method is all about, right? That's the nature of science. So we want to create a conclusion, but we also need evidence to support that theory or that conclusion. And so this helps students do that. And then it says, using the latitude and longitude of the satellite image, find it in an atlas and describe the location. Is it in a city? What state is it in? What county is it in? And then question 3 is, for each feature, describe whether your predictions were correct and then explain why. And then, so we've got in our kit a bunch of different Landsat images like this. And so another question here to think about is, what kinds of information can you get from a satellite image that you cannot get from an atlas? And so we can see these colors that give us a better understanding of texture and features like mountains and river systems. But then in an atlas, there are some information that you can get that you can't get in a satellite image. So for example, in an atlas, you would see the names of streets. You would see the names of buildings or monuments. Okay, and so this next activity, Locating Echo, is an activity that you do as you're reading the second half of the book with your students. And so I've got a link to this activity sheet that you'll get access to by looking at the presentation. And so we could see the 5 habitats that Echo is going to end up in on his way home. And so we're going to cut out this piece of Echo, and then our students are going to place it down in the particular habitat that Echo is in at that time. And then while we're reading that page about that habitat where Echo is, they're going to have to write the things that Echo was eating so that he could survive, and where he was sleeping at nighttime, or where he was hiding at in his shelter to keep himself safe. Because we're going to start opening up this conversation about food chains in this ecosystem, right? So Echo the Bat's going to eat some things, but also some things like that snake are going to want to eat Echo the Bat. And so he needs to be sheltered as well. So in my PowerPoint, I actually have pictures. And so you'll see each page where he's in the city, where he goes to the river after that, and he's going to go to the lake and forest, and then he'll go to a desert and nearby farm, and then he'll find the mountain rocks again where his mother is, and he'll be reunited. And so on this page where he's in the city, your students are going to be listening for what it is that Echo's eating. And so here in this middle paragraph, Echo thinks he's starting to feel hungry. And so he knows that by the street lights there are bugs. And so he's going to eat bugs in this city. And so where is he going to sleep? Well, he gets very tired. He needs a place to rest. So he finds a small box alongside a house. So this is a bat box that someone has made so that a bat can live in it safely. And so bats actually are really good to have around. So you shouldn't really be afraid of bats because they can actually eat a lot of bugs and mosquitoes that could potentially carry viruses that are bad for humans. So maybe you'll know somebody that has a bat box in your area and they could talk about it with your kids. I think that would be really cool. And so the next page, he goes into the next environment. And so you'll see here on the side where I've shown images of the pop-up sections of the book. And so this is what this section where Echo's at looks like from a Landsat satellite. We see that there's some kind of like mountainous feature over here. And on this side, so it's kind of like he's in a valley, and then this meandering line, which looks kind of like a river, is cutting through this mountain range. And so when you lift up the tab, you can actually see this river cutting through this plateau. And so we've got a higher elevation here, and then we go down to lower elevation where the water's at. And so this is a really great example of what we're talking about whenever we go back to a conversation about why we should get off of the Earth and use NASA satellites and remote sensing to observe the Earth and learn about the Earth. Because while we're here, we only can see so much. And so if things are changing in the environment, it's easier to see from up here when we have a bigger picture. Here's the next environment that he's at. And then here he is in the desert. And then the nearby farm as well. And then he finally makes it back to the cave along the mountains, which you can see perfectly in the illustrations, the folds due to the images taken by the Landsat satellites. Okay, so biodiversity and ecosystem. So this is a hidden picture of the Arizona desert, and in it are different organisms. And so here is a particular organism that your class can circle. Here's another type of bird that here's a bird that can be circled. Here's another, looks like maybe a very similar bird that can be circled. And so they're just going to find as many different organisms that they can. And then we also have cards, like little index cards with information of each organism that you can find in this ecosystem, what they eat, what they use for shelter, how they behave, and their genus and species names, their scientific names, and also their common names, and really good pictures that will help you find them in this image. And so you're going to count up the total number and identify the different types that are here, and then you can use this as a way to start building your food web. Like in the classroom up on the board, you can put these in groups and come up with food webs based off of this. And there's some math questions in here for your more advanced grade levels as well. And so really cool little activity. And this is available in the link that I showed you earlier. You can print this out. All right, digital art. And so the reason this is in here is because when we do remote sensing with the Landsat satellite, it comes back with just numbers, right? It senses a number, how long it takes for the light to return, and then those numbers are programmed by a computer to mean a certain color. And so it's actually a combination of getting those numbers, converting it to color, pixel by pixel, to create one big image, okay? So it's not like taking a photo with just a camera that you press a button and then you can see it. We actually have to change these using computer programs into images. And so this activity helps you demonstrate how that's done pixel by pixel to come together to make one big image. And so how this works is you're going to give a blank digital art worksheet to a student, and you're going to have them draw an image, like a smiley face or a house with the sun or this star. And then they're going to work with a partner who, and it's not shown here, but they're in our kit, we've got these labeled. So this is row A, or column A, column B, column C, all the way over. And then this is row 1, row 2, row 3, row 4. And then the students have to start up in cell A pixel or cell A1. And then, so the person that's got the blank sheet now is going to ask the person that drew the original picture, what's in A1? And so the person can say yes or no. They can say a particular color like red or green, and they're going to color it in according to what their partner tells them. So they're not going to be allowed to look directly at the image, because that's not how it works. Remember, they're acting as the satellite, the computer program on the satellite, and they're taking the information and converting it into an image that we can see. And so when they're finished, hopefully they will have matched the first person's picture, but they'll have to do it piece by piece. So they'll start with A1, then go to A2, then A3. And so this could be a really long process, and your kids will be laughing because of how long it takes. And they're not going to know what there's a picture of. They're like, what is this? I can't tell what it is until the end. It's really fun. And then since we're talking about creating colors, with light, the primary colors of light are red, green, and blue. And so in our kit, we have a red, green, and blue color paddle, or films, that you can cover flashlights with and do a color mixing activity, because we have all different types of colors that we see in our Landsat images, but they actually all come from different ratios of red, green, and blues that are detected by that satellite. And so you'll need a very luminous flashlight in a dark room to do this. And so you can just let the kids experiment with mixing colors. So here I've got red and green, which in the center you see that it creates yellow. And so that was the only one I took a video of, but you can try all the combinations out. And so I've got a link to this really cool website where you can see how, if you want to do this virtually, how blue and green would come together to add with light. It's additive color mixing to make cyan. But with pigments like paints, whenever those mix, it's actually subtractive. And so you're going to make a darker, like, green color here, an evergreen. And so this is a really neat website to show the difference between subtractive color mixing and additive color mixing. And so we're talking about mixing light rather than mixing pigments. So I have a picture of each one here. And so go to the link for the interactive part. And so yeah, those are the activities in Echo the Bat. And I think that by participating in this session, you've seen how easy it is to take a particular story and adapt it to teaching different science content. So I gave you the example of color mixing. That's a physics application. We've talked about remote sensing with that. And we did the digital art activity, which is more like a coding type of activity as well. And so on Thursday, there'll be some more information on doing coding in your classroom. To also just ecosystem studies, learning about food chains and food webs and what organisms need in order to survive in a particular ecosystem. All of these are really great things that Echo the Bat does a really good job blending into. And so I'm sure you have a favorite book or a book that you think that you would like to use to incorporate something about science. So whether it's plants or astronomy, chemistry, anything at all that you want to connect using a book. I'm sure you're thinking about it. So if you need some more help, check out the suggested book list if you haven't already done so, and maybe you can use one of those books to incorporate a science lesson into your activities for this coming school year. All right, and so if you guys have any more questions or want some help, just let me know.